Hello everyone, welcome back. In this video we're going to learn about for loops. And as you may recall from previous languages, for loops let you do a single computation over and over again a fixed number of times. And the basic idea is the same in Python, but the syntax is a little bit different. And in particular, by default, for loops are range based. To realize what I mean by this, let's do the following example. We're going to say for I in the list 1, 2, 3, 4, 5, colon, indented block, print I. And then we print 1, 2, 3, 4, 5. So the two things which are important to note is that the body, which is everything inside the for loop, has to be indented, and there's a colon at the start. This is going to be true for all of the types of loops which we introduce. So in our next example, let's try to compute 0 plus 1 plus 2 plus 3 plus 4 plus 5. So we start off with sum equal to 0, and then we say for I in, okay, let's make a list where L is equal to 0, 1, 2, 3, 4, 5. For I in L, sum plus equal I. And then outside of the for loop, let's type in answer equals sum. But we're going to want to print this. So let's print answer equals sum. Okay, so the answer equals 15, and if you do the math real quick, you can check that this is. Now let's throw us a couple of extra prints inside of the for loop in order to, so we can trace through what's going on. So at each iteration, let's print out I, and let's also print out the sum so far. So what we can see is on iteration 0, we have sum equal to 0. Then on iteration 1, the sum is equal to 0 before we do the printing, and so forth and so forth. And then eventually we get to the final answer of 15. So an alternative approach to this exact same procedure is to use a range object. Looping over the numbers from 0 to 5 or things like that is super duper common. So there's a special data type just for this. So we don't need L anymore. All we're going to do is we're going to say for I in range 6. And range 6 is the number starting from 0 up to and including, up to but not including 6. And we can see this works exactly the same way. Indeed, if we print range 6, we see that it basically is going to essentially be, it's the range from 0 to 6. And if we say for I in range 6, print I, this is going to give us the numbers 0, 1, 2, 3, 4, 5. And the type of range 6 is a range type object. So we can loop over lists. We can loop over ranges. Now the question is, what else can we loop over? And the next thing we can loop over is strings. So let's say we have a string that's equal to A, B, C, D, E, F, G. We could say for letter in S, print letter. And this is going to print each letter on its own line. Alternatively, we could use range of length of S. So we could say for I in range of length of S, print S of I. Does exactly the same thing. Now here's a little bit of a trickier example. Let's let S be my favorite quote of if you can dodge a wrench, you can dodge a ball. What we can say is for word in S dot split, print word. And this is going to print every word on its own line. If you can dodge a wrench, you can dodge a ball. Now, we do need to be careful about something. which is that indexing variables have global scope. So if I do for I in range 10, we do print I. So this prints out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You would think that this I here would be undefined, but it's actually still equal to 9. So when you create a variable inside of a for loop, it does not go away once the for loop is done. So you need to be careful not to accidentally do something stupid with this. It's pretty easy to mess up if you're not careful. Okay, now here's a challenge problem. Can you predict the output of the following code? For I in range 10, so I is going to go from 0 to 9. I is equal to I times 2. What is I going to be after we run the for loop? Pause the video and for 10 seconds, think about what the answer is going to be and see if you can get it right. All right, now that you've unpaused the video, let's check. If you guessed 18, you're correct. A lot of people did not guess 18, though. At least I'm guessing. So let's do a trace through. Okay. So let's add in some print messages so we can see what is going on. Let's print I here and print I here. So what we see is that on the first thing we have 0, and then we times by 2 and we get to 0. And now here's so the next thing we go I is equal to 1, and then I gets sent equal to 2 in this line right here. And so we printed 2. And now we have the next item up is 2, 4. But now the thing is now when we get to the start of the next iteration, I always get set to the next item in the range. So at the start of it, I is always the next item in the range. So this item here is 3, and then we do 3 times 2 is 6. But we go down to the next iteration, we do the next item in the range. So we get to a 4 and then an 8, all the way down to the end where we have a 9 and then an 18. So the answer is 18. Now, another interesting thing you can do with for loops is you can use them to create lists. So here's our problem, which we're going to tackle, is make a list of the first 10 squares, 1, 4, 9, 10. Method 1 would be to start off with squares equal to the empty list. And say for I in range 111. So range 111 means the range starting at 1 up to but not including 11. So it goes up to 10. And we could say squares dot append I times I. And let's take a look at what squares looks like. And lo and behold, this worked perfectly. So solution 1 is make an empty list. And add items one at a time using for loops. This is our empty list. And here we add items one at a time. The thing about list comprehensions, though, is it let us do this all in one line. So we just type squares equals list of I squared, or I times I to be consistent with the above example, for I in range 111. So we have I times I for I in range 111, and this will give us exactly the same thing, but only in a single line. Big, big, big time saving. So list comprehensions are generally good, although under the hood, they really do execute exactly the same way as using a for loop. Now, a more complicated example would be getting the even squares between 1 and 400. So we can type even squares equals the list of I times I for I in range 121. So this is from 1 to 20 inclusive, so it does not include the 21. If I is even, if I modulus 2 is equal to 0. Let's take a look at what our even squares look like. And lo and behold, we got all the even squares up to 400. Now, if we want to get even fancier, we can do some double indexing. So let's consider the products of all I times j, where I is either 1, 2, or 3, or j is equal to 4, 5, and 6. So we can say products is equal to the set of I times j for I in range 1, 2, 3. For I in the list 1, 2, 3, sorry. For j in the list 4, 5, 6. And take a look at our products. And we see we get all the possible products of 1, 2, and 3 with 4, 5, and 6. There's 3 items in each set. 3 times 3 is 9, and we can count up that indeed there are 9 possible combinations. Alternatively, if we wanted to produce a list of lists, we could do it instead with products 2, which is going to be the set of the list I times j for j in 4, 5, 6, for I in 1, 2, 3. And now this is going to give us a list of lists, although it looks like I have messed something up. What did I mess up? Am I missing a brace? Yep, I just needed one more square bracket. When doing these double indexing lists, it really is easy just to miss one. But now products 2 works perfectly. So this is a good time to remark on something, which is I'm typing and talking, you're typing and listening. Typing and talking, typing and listening, it's difficult to do 2 things at the same time, which means typos happen. They happen to you, or I don't know, maybe they don't. I don't know you. Haven't met you in person. They happen to me, and they really happen to most people. So if you make a typo, it's okay. Just pause the video, fix it, and then press play again. That's one of the great things about this flipped classroom format is it gives you an opportunity. If you make a typo, you pause it, you fix it, you get right back on track. I'm going to do the same, where if I make it, I'm going to search for it. And I actually think it's good for you guys to observe the process of searching for errors, because to be honest, finding errors in your code is an essential part of being a good programmer. And because we all spend way more time doing it than we would like. So on that note, this is where we're going to stop for today. I will see you guys again next time.